Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's course coverage, the topic which we will be covering today is related to the property package or property method which we use in simulations. So today's course coverage is related to the thermodynamic property package selection scheme, and we will see how and what type of property packages are available in the system, what are the importance of these property packages, how these affect the simulations, and how these are very crucial or critical once we are talking about the accurate simulations. So a property method is a collection of methods and models that which process simulators like Aspen Plus, Aspen HYSYS, DWSIM, and etc. use to compute thermodynamics and transport properties. If we use inaccurate property method or the method which does not contain the complete information, then the required results will not be achieved and the reported results will not be accurate or even prevent you from the simulation. So the property packages are very crucial. You have pasted or placed all the equipments correctly. You have prepared the correct flow sheet. You have selected the right components. But if the property package is not correct, you will not be able to get the required results. The property packages which we usually talk about or the broader classification is equation of state method, activity coefficient method, and special models. Now there are five important tasks once we are selecting the property package. Number one is the selecting the appropriate physical property method, then the validating the physical properties, describing non-data bank components, chemical species or compounds, and missing parameters, obtaining and using physical properties data, and finally estimate any missing property parameters. And our focus will be on the selection of appropriate property method. So how to select? There are four important tasks which we'll need to consider. Number one is the nature of properties, composition of the mixture, temperature pressure range, and the availability of parameters. The above paragraph again describes that the property packages are very important once we talk about the simulation, which I have already described to you. So we will go at these four steps: that the nature of properties, composition of the mixture, pressure and temperature range, and availability of parameters one by one. So talking about the nature of the properties, if we talk about the VLE, vapor liquid equilibrium, distillation, absorption, stripping, evaporation, for these equipment we need VLE. For solvent extraction or for extractive distillation, we need LLE data. For pure component and mixtures, we need enthalpies, and these are important for unit operations. For process calculations, we need density, viscosity, pH, thermal conductivity. And for equipment sizing, we need the different transport properties. And for metallurgy and mining calculations, solid handlings need to be considered in the system. So these are the six different types or six different nature of properties which we will need to consider. Talking about the composition of the mixture, that the composition and how a composition, for example, if it's a methane ethane system, if it is 40-60 mixture, the properties will be different. If it is 50-50, the properties will be different. So composition will influence all properties due to the way mixture properties are calculated. It will affect phase equilibrium greatly because of the interaction of components in the mixture. Once we talk about the liquid phase, the interaction is very, very important because of close proximity of the molecules in that phase. If the components form complexes, then the gas phase also or the vapor phase also become important in the system. And the important intermolecular forces are electrostatic, induction, attraction, and repulsion between nonpolar components and chemical forces such as hydrogen bonds. So these are the parameters which we need to consider once we talk about the composition of the mixture. Talking about the temperature and pressure range, which is very important once we talk about the phase equilibrium calculations. Methods based on Raoult's law or using activity coefficient are not accurate at high pressure or when the temperature is above the critical temperature of component. Henry's law then can be used when you have light gases in subcritical solvents, but generally not recommended for concentration of solute greater than 5%. So once you are doing some simulations, then you need to have these rule of thumbs in your mind once we are selecting a certain property package for the system. In general, equation of states or EOS, which we talk about, are better suited to predict VLE over a wide range of temperature and pressure, especially at high temperature and pressure. Talking about fourth one, the availability of parameters. Without sufficient pure component and binary parameters, it is very hard to predict or to calculate the pure component or mixture properties. So obviously you have to obtain and you have to use the experimental or literature data, or you have to estimate the properties, or you have to choose a less rigorous method, but you have to make sure that your all the parameters are available once you are doing some simulation. So these are the four important parameters which we have just studied: the nature of properties, composition of mixture, temperature pressure range, and finally the availability of parameters. These four parameters must be considered when you are selecting a suitable property package for your system. And if we talk about the different property packages, we have classified into three types: equation of state, activity coefficient, and special models. So in equation of state models, we say BWR, Benedict Webb Rubin Lee Stirling method, Hayden O'Connell method, Lee Kessler LK, Lee Kessler Plocker LKP, Maxwell Bonnell MB, Peng Robinson PR, SRK Sobe Redlich Kwong, RK Redlich Kwong, and extension of these models such as predictive SRK, predictive PR, and so on, or PSRK. And there are different types in the system. So these are the equation of state models. We will see that how these models can be used under which conditions. Going to the activity coefficient models: NRTL, non-random two liquids, electrolyte NRTL, universal quasi-chemical UNIQUAC, which we say, then universal quasi-chemical functional group activity coefficient UNIFAC, Van Laar, Wilson, Fleury-Huggins, and again there are multiple types as well. Going to the special models: API sour water method, Braun-Ketan, Chow-Cedar, Grayson Street, Kent-Eisenberg, steam tables. There are different again types available in it, but these are the three major classifications once we talk about the property packages. So we conclude our lecture to this point today, and in the next lecture we will see how we can select the suitable property package for the particular applications. So I hope you have understood all the aspects of this lecture. If you have any queries, feedback, suggestion, please provide it in the comment box and I would be happy to answer it. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.